So let us have the introduction of the vectors. First, let us see the difference between the scalars and vectors. In physics, there are two types of the physical quantities called as a scalar and vector. What is mean by a physical quantity? In physics, what we measure is called as a physical quantity. For example, when we measure time, mass, velocity, acceleration, force, energy, momentum. So what we measure, what we want to try to calculate in the physics, these are called as a physical quantities. Okay, now out of these all physical quantities, some are the scalar quantities and some are the vector quantities. The quantities which require only magnitude for their complete specification are called as the scalars. For example, if I am taking the example of the mass, suppose this is a mass, so I can just tell that this much is my mass. Okay, or when I want to state the temperature of my body, say I will say that I have temperature of 37 degrees Celsius. Okay, so I don't need to explain that direction of my body temperature. I won't say that temperature is 37 degrees Celsius in east direction. Okay, so there are some physical quantities which require only magnitude for their specification. So this is called as the magnitude. Okay, the numerical. So this is called as a magnitude. So the some entities which require only magnitude for their complete specification, these are called as scalars. I'll write it here. Physical quantities which requires only magnitude for their complete specification. These quantities are called as a scalar quantities. Okay. On the contrary, there are some physical quantities which require magnitude and direction for their complete specification. Now let us have the example of them. I am standing at this point, okay, and I have walked 5 kilometers from this point where I will reach. So your answer will depend, or you cannot answer unless and until I tell you the direction. Okay, because on this direction also I can walk 5 kilometers, on this direction also I can walk 5 kilometers, on this direction, on this direction, on this direction. Okay, unless and until I specify my direction, you cannot tell where I will reach. Okay, so if I walk 5 kilometers on my right, then I will reach here. If I walk on the left, I will reach on this point. Okay, so there are some physical quantities like displacement. So this is a displacement. Okay, the final point where I will reach. Okay, so this displacement needs 5 kilometers and on my right. So this displacement needs this magnitude as well as this direction. So these type of physical quantities are called as the vector quantities. So the displacement, velocity, acceleration, force, momentum, these are the vector quantities. And now as we are dealing, in a previous lecture we have seen that we are dealing with the mechanics. In the mechanics, we are calculating all these entities like velocity, acceleration, displacement, force, and these all entities are the vector quantities, and therefore it is necessary to study the vectors first. Okay, then we can study this mechanics. Okay, that's why this vectors, okay, it is added in your syllabus. Okay, now what I think is, it is always necessary to see why we are studying something. Okay, so we are studying vectors because we want to study mechanics, and in mechanics almost all entities are the vector quantities. That's why we are studying vectors before going into the deep into the mechanics. The scalars can be added or subtracted or multiplied or divided by using our day-to-day normal mathematical operations like addition or subtraction or multiplication and division. Okay, but these vectors, as they are having magnitude as well as the direction, they cannot be added directly by using this normal mathematical operations. Okay, so we need some different rules for the addition or for subtraction or for multiplication of these vectors. Some basic introduction of the vectors. So vector is represented by arrow on a some symbol like vector O, vector A, vector B. Okay, so vector V, vector A. Okay, so the arrow on the head, it means that it is a vector quantity. It requires both magnitude as well as direction for its complete specification. Let's see how these vectors could be resolved. Actually, you have already used the resolution of the vectors in a previous year like 12th standard. Okay, suppose if I have a two-dimensional Cartesian coordinate system with a x and y axis. Suppose there is point P, O is the origin. Let P be the magnitude of this vector. So this is vector, this is vector, this is shown by the arrow. So this is the head of the vector and this is called as a tail of the vector. So let us have this distance as a py and this distance as a px. Okay, so the magnitude of this vector is p, magnitude of this part is py, and magnitude of this part is px. Now suppose this is the angle theta made by this p, vector p, with this px. So from this triangle OPB, we can write that sin theta is equal to PB upon OP and cos theta is equal to OB upon OP. Okay, we know that this PB is nothing but PY and this OP is nothing but P. This OB is PX and OP is nothing but P again. So I can write that this PY is equal to P sin theta and Px is equal to P cos theta. And togetherly I can write this vector P is equal to Px cos theta plus this Py sin theta. Or I can write it P is equal to Px plus Py. So what is the meaning of this actually? Now it says that if there is a vector P which is making some angle theta with this Px, okay, then Px cos theta and Px Py sin theta will be the components of the vector. Components of the vector P. Or we can also say that this vector P can be resolved resolved into the px and py. Actually, you have used this concept of the resolution. This is called as a resolution of the vectors.